The Streamable Assets Manager, also known as S.A.M, is a solution for creating, managing, and dynamically streaming compartmentalized assets in order to form complex game worlds. The basic idea is quite simple. Rather than loading the entirety of your game world all at once like you see here, you break the world down into streamable cells, each with their own assets. This allows you to remove the extra bits in order to create a game world that contains only the assets you need at any given time. While this primarily aids in reducing the amount of RAM your game uses, allowing you to target a wider range of hardware, the reduction of assets in the scene usually has a positive effect on the game's performance as well. Streamable cells can be unloaded and loaded manually via API calls, which offer a tremendous amount of flexibility. However, it is usually more typical to let S.A.M track transforms in order to automatically load and unload cells based on manually configured loading patterns. As this transform, which is usually your player, moves about the world is updated as needed. And of course, you are not restricted to tracking a single transform. Multiple transforms can be tracked to support split-screen co-op games or other custom features. When tracking transforms, the pattern of cells that is loaded around the transforms is under your complete control. You can use simple ring-based patterns or more complex custom shapes. You can even define unique patterns for each individual cell that the player might be standing in. Each streamable cell in S.A.M can make use of one or more asset chunks, which are the actual assets that are loaded and unloaded when a cell is loaded and unloaded. An asset chunk may consist of a single asset, such as the terrain assets seen here, or it may consist of tens or hundreds of individual assets to form a more complex asset chunk, like the forest area that has just appeared. In truth, the forest area is actually 10 different asset chunks, all of which belong to the same streamable cell. Splitting up assets into multiple asset chunks is a powerful technique that can help alleviate performance issues related to loading, unloading, activating, and deactivating asset chunks. Asset chunks will typically be in the form of prefabs or scene assets. However, other types of assets can also be supported, though doing so requires programming expertise. Addressable prefabs and scenes are also automatically supported by default. Each world can utilize multiple groupings, with each grouping typically being made up of related asset chunks. Groupings allow you to organize your world into logical layers, which provide a host of benefits at runtime, and while iterating on your world in the editor. Two of the most important of these benefits are the ability to define unique cell sizes for the streamable cells on each grouping, and the ability to load the cells on one grouping in a way that is isolated from the cells loaded on another grouping. Let's explore these concepts now. In this example, we have a grouping of terrain that forms the base of our world and a player at the center of the middle terrain. We also have a separate grouping for tree assets, with cell sizes that have been configured to be equal to the cell sizes of the terrain grouping. By placing the tree assets on a separate grouping, we can choose to load a smaller area of trees than terrain, which is advantageous since the tree assets are smaller in size. At farther distances from the player, their absence will hardly be noticed. The same cannot be said for the terrain assets. Unfortunately, the large size of the tree cells means we can only remove large areas of tree assets, since the removal is achieved by loading less tree cells. Using smaller size cells, as we are doing with the vegetation assets being loaded in now, gives us more fine-tuned control over the area of assets that are loaded. This effectively allows us to reduce the load area in smaller increments. By combining multiple world groupings together, we can create a rich and complex world that is updated dynamically as the player changes location. Using special customizable transition classes, we strive to make these updates as inconspicuous as possible in the hopes of convincing the player that the entire game world has existed from the start and will continue existing no matter where they travel. With this video, we hope you have a firmer grasp of what S.A.M is and what you can achieve with it. Of course, this video only covers the end goal of creating complex worlds that can be presented efficiently to your player base. We'll touch on some of S.A.M's other functionality in another video, such as the incredible World Designer tool that allows you to convert large, over-bloated scenes into streamable asset chunks, and then manage those chunks inside the Unity editor in an effortless way that makes iterating on your game worlds easier than ever. If you haven't already, consider becoming part of our ever-growing Discord community, or join the discussion on the Unity forums. Links for these, as well as the asset store page of S.A.M, are provided in the video description. For now, take care and keep on developing.